smaller one, it was unreal heavy. Like I just had to like game face, like put my head down and just keep walking because I was like, just if you stop, you won't start again. It was so heavy and it was so hard. And yeah, this is how they carry it. And this is where they get their water. So this is their water for their village, and they scoop it and they drink it. And if I drink that water, I would be deathly ill. And it's because their immune system is built up towards that water, but also they live with a higher level of maybe Giardia or different organisms, but still it's not healthy. And yeah, if you ever are interested in water rights and things like that, I would love to talk to you about it. Okay, so what a non-communicable disease is, and I'm sorry, go ahead.
I had a question regarding like infectious dose.
Yeah.
And so they could drink the water right out of the pond, or whatever. And obviously you couldn't.
Yeah.
But if you were to drink the same amount of water, you would hypothetically be getting the same infectious dose, but you would get sick and they wouldn't.
Yeah.
So what is the difference? Because whatever sickness is, it has the same virality.
Yeah. Yes.
Right?
Yes.
So,
very good point. Awesome. Yeah. So the reasons that I would get sick and they don't are, one, their immune system has been built up to that probably for generations, so that they have a stronger immune system than I have for sure. But also, like my mom that went to India and she got Giardia. A lot of people have lived with Giardia so long that their body can tolerate it, and just because their body can tolerate it, they probably live in a more malnutrition state because their intestines can't digest the same amount of food that ours can. So somebody that's had Giardia for a long time, they eat small amounts of food and they can tolerate it, and they don't have the same like crazy infestation all at once. And so yeah, there's a few little reasons behind that, but infectious dose hypothetically is the same for each person, but that's not really the case either. That's a good point. Awesome. And we'll talk about infectious dose and what that means. Okay, so we're not going to talk about non-communicable diseases in this class. So these are diseases that you cannot catch person to person, like genetic diseases, heart disease, that's COPD, stroke, cancer. These are the most common diseases that are from diet, sedentary behavior, genetics, things. But we're going to focus on communicable disease in this class. So communicable disease or infectious disease are the diseases that we focus on. So communicable disease are things that you can pass person to person. The most common in the world is tuberculosis. The second is HIV and AIDS, but it's pretty up there with enteric infection, so any intestinal infection. And then malaria is also extremely common, but we'll learn all about that. So here are our terms. So communicable infectious disease, I just talked about that. What an endemic disease is. So an endemic disease is occurring in one area. So if it's endemic to that area, we'll talk about a few examples of diseases that are endemic, like that's been in the news lately. It's called valley fever, and it's from a fungus, and that's endemic to certain areas like Southern California. So that's what endemic means. And you don't have to know, I don't want you to memorize word for word verbatim, just kind of understand what it means, and you can give an example if you can't quite put your finger on it. I'm super lax with things like that, so as long as I kind of know what you mean and you know what I mean, then full points. Epidemic, so an epidemic, I'm sure you guys know these terms so well now, but a lot of people probably don't really know what they mean. But an epidemic is a breakout in a specific region, and then a pandemic is breakout in multiple regions, usually multiple countries or around the world. What pathophysiology means, we're going to talk a lot about what is the pathophysiology, and that's the path to infection. So well, I think the origin of that term means suffering or something like that. So how the suffering occurs and the path to that. Etiology means cause. And then epidemiology means it's like health statistics. So when you give statistics of, you know, what are the socioeconomic variability of Folsom, that's not health related. So epidemiology is, you know, how many people have HIV in the greater Sacramento region, something like that. That's epidemiology. Okay, so we're gonna talk, I'll let David Staves go. Is that okay? Are you good to go now?
You know, I'm looking at my calendar and I think was now the right time, or
it was, oh, I thought it was before lecture. It's okay. No, I think we had a miscommunication, but it's no big deal. You can come now.
That's good.
Totally, yes, okay. Absolutely. Okay, so I introduced you a little bit at the beginning of lecture, but I will just let you go ahead and do your spiel. So this is David Staves.
Sounds good.
Great, oh, here, let me pull your little slide again.
Good afternoon, everyone. Sorry for the miscommunication. I apologize. Anyways, my name is David Staves. I am a success coach here at Folsom Lake College. Wanted to just drop by for a few minutes and give you an idea of what success coaches do and how we can support you as a student here at FLC. I am the STEM success coach. Success coaches are broken up by major, and that's not because we can't help you with other things, but just to help spread out the load. Regardless, even if you're not a STEM student, you're more than welcome to ask me questions. We help and support students with pretty much everything, with the slight exception of being able to plan out your classes and tell you specifically what classes to take. Our job is to be familiar with all the different services that are available to support students at FLC and to get you connected to those services. So if you need a counseling appointment, we can schedule one for you. If you need help understanding financial aid and walking through it, we can guide you through that process. If you have questions about textbooks or about financial resources or basic needs like food insecurity or housing insecurity, or the list goes on and on and on, we're here to help. Folsom Lake College has a ton of different resources that are available, and we don't expect students to be aware of all of those. So we have success coaches so that all you have to remember is that you can come and talk to us. Even if you don't know like how to articulate the concern that you have, we can help you to troubleshoot it and walk through it. We also work with your instructors. So if your instructor sees, any of your instructors see that you might benefit from a service that's available on campus, or sees that you may be struggling, then they may ask us to reach out to you and touch base with you and see if we can help you out in any way. It's not because you're in trouble or you're doing bad, it's just because your instructor cares about you and wants to support you the best that they can. So yeah, we've got this slide here with my contact information. You can also find us online if you just Google FLC Success Coaches. Here on the main campus, we're located in the Welcome and Student Success Center. So if you're entering that main building and you go down the ramp on the left-hand side, against the back wall of the Welcome and Student Success Center is a whole bunch of cubicles, and that's where you'll find us. If our doors are open, you're more than welcome to come talk to us. My cubicle, my window has Baby Groot from Guardians of the Galaxy, and so you'll know which one to find me in. But otherwise, I think that's all for my spiel. I do have, if anybody wants a business card, I've got some business cards I can blend. On the back is a QR code to set up an appointment with me. But otherwise, any questions or anything I missed?
No, I did a little introduction before you got here too, so yeah, we covered a lot. And yeah, so just if you guys need to reach out to David, he's awesome and tons of help. And use your college resources because we offer them.
Okay.
Yeah.
And they're free, right?
Awesome.
Like,
yeah.
You don't have to pay.
Amazing. Right.
And then I'll touch base with you. Sorry.
Okay. Yeah. No. It was probably me. It's no big deal.
Did I miss anyone? Anybody else need a card? No problem. Enjoy the rest.
All right. Thanks so much, David. Okay. So we're moving on now. We're done with our little history section. I'm going to try to blow through this section a little bit because I want to move on to infection and how an infection happens and what's going on. But I'm just gonna go over, I talked a little bit about our phylogenetic tree. And here, so we'll talk about what these words mean and what they are. But first, really quick, let's go into how we name things. So here, we kind of consider this, I guess we would call it a domain. So here I wrote on here our phylogenetic tree. What is a phylogenetic tree? It's how organisms are related by ancestry and genetics. And then our three main domains. So we have three main domains, 1, 2, 3. But the reason I don't really like this is because these two are closely related and this one is not closely related. So I'll show you that in a minute. But here's bacteria that we're going to spend a ton of time talking about. Archaea that we're going to talk about for probably 20 minutes. And then eukaryotes that we're going to talk about the whole second half of the semester. Viruses are first half of the semester. And I'll tell you why they don't belong in this tree. Okay, but as we move from the domain, we kind of skip all of these brackets until we get down to our two main brackets. So I'll tell you what those are. But this is the mnemonic that I've used since I was in school. So kings played chess on fine grained sand. Have you guys heard that one before? There's other ones that you may have heard, but this is the mnemonic for it. So it's KPCOFGS. Kings played chess on fine grained sand. And what those are here: kingdom, phylum, class, order, family, genus, species. So we take one organism and we say, okay, is it related by kingdom? Is it related by phylum? Is it related by class? So like genus and species, so like we are in the same family, and I'm not sure how far up we go with like apes, for example, the greater apes or the lesser apes, or I'm not sure how we're related, which class, order, family we're related, but we are Homo sapiens and we're on our own genus and species. Oh, but here it looks like we're related all the way up to the domain. So it depends on what organism that you're talking about, but we're gonna forget all these. I want you to know this mnemonic because you'll be asked it again over and over, but kings played chess on fine grained sand, kingdom, phylum, class, order, family, genus, species. But these are the two that we're gonna focus on, and that's called binomial nomenclature. Crazy, long, annoying word for two names. Two names. Binomial nomenclature, two names. Genus, species, that's what it means. So I wrote it out here, how you write genus and species. So if I still, on the final, we're taking points off for students doing this wrong last semester, it was killing me. But genus and species, we always write it, if you're typing it, it's in italics. Or it's in italics if you're typing. If you're writing, we don't write in italics. We just write how we write. If you're writing it, you underline it. Always. Always. And that's if you take botany. That's if you take zoology. That's if you take anything. You write it out and italicize it if you're typing it, or you underline it if you are writing, handwriting. So the first is the genus and the second is the species. So there are a lot of different, well, I don't know a lot, there are different species that belong in the, like for example, Staphylococcus aureus that we talked about last time. Staphylococcus is the genus, aureus is the species. There are many different Staphylococci genus that belong in that genus, but there's only one species that belongs in Staphylococcus aureus. So we're all Homo sapiens, but we're all a little bit different, right? Thank goodness, it's a beautiful thing. We're all different. Same with Staphylococcus aureus. Staphylococcus aureus is the the same genus and species, but there are different strains. So you can think of us all as different strains of Homo sapien. So there are different strains, but we focus on genus and species, and we'll go over that again and again. Okay, so here's some different examples. Here's Escherichia coli, Methanobrevibacter smithii, and Plasmodium falciparum. You don't have to know those, but just some examples of what as you go down their domain, their King's plague chest on fine grained sand, their kingdom, phylum, class, order, family, genus, species for each of those organisms. So the ones that we learn in this course, you don't have to memorize this, you'll know it as you get later. We do bacteria, archaea, viruses, fungi, protozoa, helminths. These all belong in the microorganism world, and we're going to talk about each of these. Okay, so here are just some more terms. Taxonomy, phylogeny, phylogenetic tree, nomenclature, binomial nomenclature. We already talked about those a little bit. Okay, so let's move on to infection. Okay, so path to infection. So this is chapter 11, and chapter 11 maybe will seem a little bit dry, but it's important because this is the whole CDC's job. Just as a little, I will try and give you some little advice as you go along, but if you are interested in the medical field at all, the CDC, the NIH, World Health Organization has really cool internships. So if you're ever interested in that, go on their website and see how the internship situation works out. Sometimes you can work for what's called an NGO, or a non-governmental organization, and you can volunteer in places like Mexico or places like Cuba, or things like that. So super cool volunteer opportunities. Do it now while you're young. Before you have kids, if you already have kids, do it anyway. Okay. So I just threw this on here because keep this in mind. I've seen this on the TEAS. This is straight from the TEAS examples, but they want you to know the path to infection. And their path to infection, the way they listed it, is a little bit different than our book lists it. My guess is that the TEAS will change to be a little more, how do I want to say it, to clarify some of their paths a little bit better, but you without trying to be so rigid with your path, step 1, step 2, step 3. It's just all, you kind of get there. You know how you get sick. You know how people get sick. You've been sick 1,000 times. Everybody knows how you get sick. We have these specific brackets that we put them in because we're human and we like brackets, but really just keep it on a general level, a general sense of how people get sick. Okay, so our first is called a portal of entry. Then we attach and negotiate the microbiome. I'll walk you through all these. Surviving host defenses, causing damage and disease, and then we exit the host. But I'm going to throw on here the method of transmission of how it transmits from person to person or animal to person, because this is actually involved in the path to infection, and that's how the TEAS does it. Okay, so let's go through these one by one. So I picked this picture on purpose because I love their little. Okay, so portal of entry. They look like they're dancing. So the main idea is that there's a portal of entry specific to that disease. If you sit on a toilet seat that has COVID on it, will you get COVID? No. If you drink from a straw with someone with HIV, will you get HIV? No. The portal of entry has to match the organism. And the portal of entry is specific for every single organism. And the reason that is because something called tissue tropism, and we'll go over that term again and again. But tissue tropism means the specific tissue that organism infects. So COVID infects respiratory cells. It can't get in anywhere else. It can't get into skin cells. It can't get into the lining of the vaginal wall. It can't get into ears. It's specific to the cells that are in the respiratory tract, and that's the only cells that they know how to infect, that they match with, that they can get in and out of. Every other cell, it's just like a piece of dust. It makes no difference to us. So that's called tissue tropism. So I don't want you to memorize, you know, if you ever have a question like, do we need to know that? Just ask me. I don't mind that question at all because I put a lot of information on here, but mostly it's just so that you understand what the heck I'm talking about. So the area of exposure depends on that organism, is what I was trying to say. So the next step on the path to infection, so they meet their match, they met their tissue type, but now they have another problem. If I'm a Staphylococcus aureus bacterium, if I'm one bacterium and I'm looking for my specific tissue type, I found my specific tissue type, but now I run into problem number 2. I have to attach and fight the commensal organisms. So the organisms that already live there. And I'll go over what commensal means later on, but basically your microbiome, we're full of organisms, covered in organisms. Remember, we're mostly microorganisms. So those new organisms are like, hey, I'm a foreign invader, and those other organisms are like, get the heck out. No, this is our home. So they have this little micro environment where they're happy, and they'll kill other organisms. So if you're a Staphylococcus aureus, you have to fight off the organisms that are already there to survive. So that's attaching and fighting the microbiome that already exists. I'll talk more about commensals, don't worry about that word now. But this is called bacterial antagonism. Have you guys heard of that word, antagonist? So there's like a protagonist and an antagonist. When we talk about literature, that's as much as I know about literature. It's not my field. But bacterial antagonism is bacteria that are already present that are fighting off new bacteria that are trying to attack that tissue type. Okay, survive host defenses. Now this is the biggie. So we have a very potent immune system. Our immune system, we would all be dead without it. And humans, I'll talk more about that when we get to the immune system. Humans that are born with an immune system that doesn't work very well don't live very long. Sometimes they can live in a bubble for 2, maybe 3 years, but generally babies that are born without an immune system will die within minutes to months, and if they do survive years, they have to live in a bubble without microorganisms infecting them. So our immune system is incredibly potent, and that's why we're not all sick right now. You know, you probably know somebody that's sick right now. Like, we don't have it, it's because our immune system is fighting it off. So here are some of the terms that go along with that. Your patient that is immunocompromised is vulnerable to all kinds of infections. So without getting in the weeds of what HIV is, because you'll learn about it later on, but HIV is a virus that infects the immune system. So an HIV patient has a vulnerable immune system. So they end up dying from a cold or a rash or a cut or something like that, because they'll get an infection, because it's like back in the 1800s where we didn't know how to stop it. So a patient that is immunocompromised, such as a patient that's on chemotherapy, a patient that is has some sort of genetic malfunction with their immune system, a patient that has HIV or AIDS, a patient that has other what are called comorbidities, who has diabetes, who has already heart disease, who's a smoker and has emphysema, and they're immunocompromised, and so they're leaving themselves vulnerable to infection. The opposite of immunocompromised is immunocompetent. So immunocompetent, yeah, go ahead.
Is there like a scale that's used to measure degree of immunocompromised, or is it more of a binary category?
That's a really good question. So when we get to our immune system section, you'll see our immune cells. When you get a CBC or a complete blood count, like when you get your blood drawn, they'll tell you how high all of your white blood cells are, how low they are, and so you can tell in that way. But also people that have a normal immune system, all of their parameters look normal, but their body is just overworked from diabetes, or their blood vessels, the wall is thin and their blood vessels, so bacteria can get through easier. You know, so it depends what it is, but yeah, that's a really good question. Sometimes we can measure it, and sometimes we can't. Sometimes just patients, you know, like HIV patients, on the CBC, you'll be able to tell if your patient has HIV or not. But, you know, if it's something like heart disease, they're just vulnerable because their body's working so hard to keep their heart going. Yeah, awesome, great question. So what we call pathogens some kinds of pathogens we call opportunistic pathogens. So opportunistic means a pathogen that doesn't make anyone else sick. Everybody else is fine with this pathogen. The pathogen is gonna make somebody sick if they're immunocompromised. So if somebody's immunocompromised, it will make them sick. If somebody's immunocompetent, it won't. So that's called an opportunistic. It takes the opportunity to take advantage of somebody that has a low immune system. So those are called opportunistic pathogens. We wrote that down on our note card for Staphylococcus aureus, because Staphylococcus aureus is everywhere. It's all over us. It's in our eyes, in our ears, in our nose, in our mouth, in our intestines, and everywhere is Staphylococcus aureus. But we don't get sick. We don't get sick unless we have some sort of immune system malfunction, unless it's a strain that's highly virulent, that's gonna, like MRSA, or a patient has something else going on. So those are called opportunistic pathogens. Tuberculosis will make everybody sick. That's not an opportunistic pathogen. Staphylococcus aureus is an opportunistic. Yeah.
So the immunocompetent, that's just basically someone with a healthy immune system.
Yes, perfect, perfect. And then virulent, or virulence, is how strong, how potent that organism is at making people sick. So Ebola is highly virulent. Coronavirus, before SARS-CoV-2 mutated, it was had a low virulence. But then there was a mutation. Then it was extremely virulent and made everybody sick. So virulence is how you measure the potency of an organism. Okay, so surviving host defenses, I just put a little thing about that, just so you can read that on your own. But I'll talk more about this little guy with the sprayer, and when we talk about evolution and genetics, because strains can become more virulent, can become more resistant to antibiotics and things like that, and I'll kind of talk about that later. But this is the most important. This surviving, having a working immune system is the most important thing. Nothing else is as important as having a strong immune system. If somebody has a low immune system, they're vulnerable to everything. If somebody has a strong immune system, then most of the time they're not sick. I was always touting my ability to fight off COVID because I never had it, and I didn't have it the whole time everybody had it, and then I got 2 vaccines, and I haven't had more vaccines after that, but I was like, I've never had COVID, and I just got it like 3 months ago, and it took me the heck down, and nobody else, like everybody else is like, oh, I'm mild, or I don't, it's because they had it, and I had never had it, and so like I got a lazy eye, my eye still isn't quite right, I had such a gnarly infection that it infected my cranial nerves. So, yeah, and I was like, I have such a strong immune system. No, you never say things like that because you know it's just gonna come and kick you in the butt. Yeah.
Are there drugs you can take to improve your immune system for like people who are really comfortable, not just like over the counter, but like things that actually will really like help someone?
So pharmaceuticals to improve the immune system, not really. The best thing to improve the immune system are vitamins, a healthy diet. That's
So they're kind of just on, you just have to live with it.
Yeah, you know, and there are things that they can do to help fight infection. So like for somebody who has had an organ transplant, for example, has to take pills that will compromise their immune system so their body doesn't fight off the organ. So they're always immunocompromised. But then they can take other, there's pharmaceuticals that they can take that will help boost their immune system somewhat, but not really. Really, it's diet, exercise, yeah, rest.
Do you think there'll be like possibilities in the future for people who can't survive, like babies that are born with no immune system?
Yeah, they're doing a lot of research now, and if you guys are ever interested in looking into it, this is a crazy cool thing that they're doing now. And I'm not all up on the science as of today either, but they're using antibodies. They're using so they'll take out your white blood cells, manipulate them, and put them back into your body so that they will attack whatever it is that you're fighting off. Yeah, so they will like genetically improve your own immune system and put it back. But that's the thing, is like using other people's cells is always going to be a problem. So it has to be from your own immune system. So they're doing that now with like cancers and things like that. Yeah, cool.
On the topic of organ transplant, do you always have to take medication, or does eventually your body start trying to fight off the organ?
That's a good question. I think it's lifetime as far as I know.
Pretty sure it's lifetime.
Yeah, like as far as I know. I have a friend who had a liver transplant, so I can ask her. She would know more than me, but yeah, really good question. Awesome. And when we get into the immune system, you guys are gonna love that section because it's so crazy. It's really interesting. Okay, awesome. So now, okay, it's breached all of those levels. So now it found its tissue tropism, it found its portal of entry, it fought off the host resident microbiome, it fought your own immune system or your patient's own immune system, and now it's ready to make that person sick or your patient sick. So what's happening is it's just living the dream. Like if that Staphylococcus aureus all it's doing is trying to survive. It just wants to survive, just like we all do. So it's just trying to find food, trying to reproduce, trying to find an environment where the temperature's just right and the environment's just right and the oxygen's just right and all of the things that are just right. So once it's found all those things and it's an official infection, what happens now is it undergoes these things called cytopathic effects. So cyto means cell, patho, remember that's like the suffering. We use that for pathophysiology or pathology or whatever, we use that term path. So cytopathic effects. So this is how that organism affects that cell type. What does it do? It does all kinds of things to either kill cells or infect cells, break down cells, change cells. It does things to that cell depending on what it is. And we'll learn a lot more about that, about what it's doing to the cell itself. But just for right now, we know that it's gonna cause cytopathic effects. So what our bodies will go through is inflammation, immune response, fever, other signs and symptoms of the disease like body aches or rash or whatever it's gonna cause, and sometimes it can cause death. So now this illness that the cytopathic effects are causing are the result of that infection. So you can read through those. And then the portal of exit. So the portal of exit is not always the same as the portal of entry, but I just put a little information on here just if you want to read through it. But you know, it's just something to think about. The portal of exit is not always the portal of entry. It depends on the organism itself. So, for example, the portal of exit is always different, thank goodness, than the portal of entry for something like a gastrointestinal infection. You eat a gastrointestinal infection and you poop it out, you know, so the portal of exit is different than the portal of entry. Okay, so the transmission. So we're going to talk more and more about transmission as we go along, so don't stress about it too much for right now, because we're going to talk about how things are passed from like mosquitoes, or how things are passed from patient room to patient room. We'll talk a little bit more about that in lab today. Or how, you know, it's passed through the HVAC system, and hospitals have to worry a lot about their heating and air conditioning systems. Are they passing around infections from their heating and air conditioning system? So depending on how things are transmitted, and yes, you know, try to, as you're going through some of these topics and some of these terms, they can seem dry and they can seem boring, but think about, okay, I work for the CDC and I'm on an Ebola team. And if I'm on that Ebola team, how I'm in this jungle and I'm in a village and I have 10 houses I'm gonna go to, how are these patients related? How did they touch something? Is it in the water? Did they touch a pen? Are they sharing food? Is it in the soil? So all of those questions they're big questions for a lot of the infections. And you know, for COVID, for a long time, we had no clue. We didn't know. You know, people were like, it's in the air, it's in the water, it's, you know, you can be 20 feet away and you can get it. It's, you know, and people were losing their minds over it, and we didn't really know how it was passed. Until then, you know, scientists worked and tried to figure out how narrow it down of how it was passing person to person. So that's when the masks came into play. So let's talk about direct transmission and indirect transmission, and then we'll finish here. So direct transmission is direct contact. We'll talk more about what that means next time. And then indirect contact is when it's passed through another substance or thing. So direct contact, you might think, okay, that's face to face, but also it's any kind of respiratory droplet. There's nothing that's between you and your patient, or your patient and another patient. So that's all considered direct contact. Where indirect is, I touched a pen, my patient touched the pen. The fly landed on poop that was infected and got to me. So that's indirect transmission. Okay, so we'll talk about that next time. Okay, so let's go ahead and do our note cards. So grab a note card if you need it. So last time we talked about Staphylococcus aureus. We're going to look at these in the microscope today, and they'll look something like that. We talked about how we already know now. Well, no, we don't know hardly any of that. We know what opportunistic means. That's one thing we know so far. And these are the tissue tropism, the tissue tropic types of Staphylococcus aureus. Skin, eye, they have a lot of tissue types, right? But they're opportunistic. So most people are not infected if they have a healthy immune system. Not everybody. Like example, my husband is a MRSA carrier. He is a paramedic and picked it up at some point in his life, and now he is a MRSA carrier. So he just has to be mindful of it, of you know, if he has a staph infection, that it could be MRSA. But we'll learn more about that. Okay, so here's our note card for the day. So here's what it looks like in the microscope. It's not purple. We're gonna call this red. And then here's what it looks like in a cartoon drawing of it. So this is Escherichia coli. Say it 3 times with me. Escherichia coli. Escherichia coli. Escherichia coli. Escherichia coli. Escherichia coli. Good. What does coli remind you of? Colon. Yeah, colons. This is an intestinal bacteria. Yep, these are flagella. Yep, we'll learn about those next time. These are what help propel them. They're called flagella. flagella that help them move. And it's this little pill shape. We'll talk about that. Okay, here's the back. So here's the white, and here's the white. So less frequent. I actually do want you to write that down, even though I'll tell you what to memorize as we get towards the end. But I do think you should write it down just because it'll come up. Yeah.
So is this a genus species?
Oh, great question. Yeah. So Escherichia is the genus. Coli is the species. Yeah, underlining it every single time is a fantastic idea. Then you should get in the habit of it. Great. So nothing in the gray. You don't have to write down any of this stuff. But yeah, none of this. This is just for your own information. I'll talk about that. But this stuff write down, you don't have to write this either.
In here, or am I crazy?
It's not too. Is anybody hot? Not too hot today. Yeah, it's been hot. It was hot last class, I thought. But
is the air conditioner bad, or?
I don't think so. Not
or
that
are you
I've
actually giving people sicknesses?
Hopefully not. That would be bad.
Because what if you're an asymmetric carrier?
Yes, yeah, asymptomatic, you might be. That's true. A lot of people are. Okay, so this this organism is gram negative. So that little dash it's a gram negative. You'll know exactly what that means next week. It's a bacilli. So the last one was a cocci, which is round. So this is a cocci. You'll learn more about this later, so don't stress about it now. This is a cocci. And this shape is a bacilli. This is also called a rod. Gram-negative rods. If any of you are how many people work in a clinical setting now? A lot. Oh yeah, holy cow. So I'm sure you've heard of gram-negative rod. Maybe you haven't, but gram-negative rods are something to worry about. So that goes around a lot. The term goes around a lot in a clinical setting. So they're modal, which means they can move. We'll talk more about that. They're enteric, which means they're intestinal. The way that we're going to identify these beads in the lab are rapid lactose fermentation, and you'll know what all those words mean soon. 700 strains of Escherichia coli, and the different strains.
Wait, E. coli? Isn't that the bacteria that's in Chipotle food?
So yes, it has been. There was a big thing in Chipotle food that went around, E. coli. There was a big E. coli outbreak in Chipotle food, and in other organisms, and other foodstuffs, because if it lives in the colon, then where is it?
In the stool.
In the stool. If it's in the stool, and for example, if animal fertilizer still has E. coli in it and hasn't been treated properly and goes to fertilize fruits and vegetables, it'll be in the fruits and vegetables. Or if animal runoff is in people's water, then people can get it from water. If it's human feces gets on a pen or on an iPad or anywhere, you know, human feces are everywhere in a medical setting. So not getting that in your mouth or in your next patient's mouth, things like that. So we'll talk more about transmission, how that works. Okay, so these are different toxins that are spit out by different species. So you don't have to know this. You might need to know this in nursing school. I'm not sure if they'll teach you that or not. But these are different types of toxins. One that we worry about a lot that you'll hear about in the news is this shigatoxin producing E. coli, and that's this O157H7. that you might hear about in the news that produces Shiga toxin. So most frequently, they cause gastrointestinal infections. If you've heard of traveler's diarrhea is generally from E. coli. So I get that every single time I go to Mexico without fail. Dysentery. So dysentery is bloody diarrhea. That's what dysentery is. So diarrhea is just loose stools. Dysentery is bloody stools. Genitourinary, so UTIs, urinary tract infections, are extremely common, and we'll talk about what those are. So respiratory, it can cause pneumonia, and we'll talk about what HCAP means later. It can cause meningitis. It can cause cardiovascular diseases such as sepsis or HUS, hemolytic uremic syndrome. So we'll talk more about that. We'll talk about what fecal oral transmission is.
Can you please show
this is what an E. coli looks like compared to a Staphylococcus aureus. So this E. coli, it has flagella, this is a bacilli, this is a cocci, and hemolytic uremic syndrome is where those toxins will break apart red blood cells, causing blood clots. Okay, so you guys take 10 minutes and I will meet you at 40 after in the lab. Did you go back to that slide? Oh, yes.
Do we turn in the flashcards?
Yeah, turn in the flashcards on that back table on your way out, please.